Welcome to Lesson 6.2, Multiplying and Dividing Radical Expressions. In this first segment, we're simply going to deal with multiplying the expressions. There's a few things for us to look at. First off, in order to multiply or divide, the two terms have to have the same root. For example, they both have to be square roots, or they both have to be the cube root. You can combine them under one radical sign. This allows us to factor tree everything together. If you have a cube root, you can pull out groups of 3. If you have a fourth root, you can then pull out groups of 4. Anything that gets pulled out of the radical can be remultiplied. And anything left inside the radical is also remultiplied. So let's see how this works. In the first two examples, all we're going to do is simplify. So number 1, I want the fourth root because of the 4. 256 s to the 7th, t to the 12th. So what I'm going to do in this lesson is go ahead and factor tree the 256. Okay, this is what my factor tree of 256 looks like. I'm going to look for groups of 4. So right here are 4 2's. I factored the 4, the 8, and the 16. Over here along the side, it's another group of 4. The 128, 64, and 32 were all factored down. So I have 2 groups of 4. I'm going to pull each one out. This group is that 2, and this group is that 2. So the fourth root of 256 is 2 times 2, which is 4. S to the 7th, how many groups of 4 are there in S to the 7th? If it helps, you can write them out. There's 4, 5, 6, 7. So here's one group of 4 I'm going to pull out, leaving these 3 inside the radical. T to the 12th. If you don't want to write them out like we did the S's, you can think to yourself, how many groups of 4 are there in 12? There are going to be 3. 3 times 4 gives you 12. So my final answer is 4s t cubed with the fourth root of s cubed on the inside. All right, go ahead and try number 2. Push pause while you do your work, and then when you're ready to check your answer, go ahead and hit play again. All right, here's my work that goes along with number 2. I factor treed the 125, and I got 5. The y squared, there was only 2 of them, so I couldn't pull it out, which is right here as y squared. There were 4 z's, so I took 3 of them out. That's 1 pair. And then 1 left over. 5z times the cube root of y squared times z. Now let's try number 3 and number 4, where we're going to actually multiply 2 different terms. So like I said in the beginning, I always like to put them under one radical sign. So I'm going to bring my numbers together. 50 times 15. I'm going to bring my variables. X squared, there's no other x's. I've got y cubed, and there's no other y's. And then I have z to the 5th, and 1 more. If you have 5 z's and 1 extra, together, that makes it z to the 6th. So let's go ahead and multiply our numbers. 50 times 15 is 750. and I'm looking for the cube root. So I need to factor tree 750 and look for groups of 3. This is my completed factor tree. So let's walk through it. I took 50 times 15 and got 750, and I factored it down. Each time I factor a number, the 6, the 30, 150, 750, it's a good idea to go ahead and cross them off. Look for groups of 3. So there's my group of 3, and that gets pulled to the outside of the radical. So when I set up my answer, I'm going to go ahead and put the radical sign, the cube root, and that way I can place numbers on the outside and on the inside. So here's my group of 5s. The 3 times 2 gets remultiplied and put back inside. There's the 6. Looking at my variables, I simply rewrote x squared out to help visualize. There's only 2 of them, so I can't pull it out. It stays inside as x squared. Y cubed, that's one group of 3. See how there's one group and gets pulled out once. Z to the 6th, how many groups of 3 are there? Well, there's going to be 2. You can also do it as 6 divided by 3, giving us z squared. There's nothing left over, so that is my final answer. 5yz squared times the cube root of 6x squared. Okay, go ahead and try number 4. Push pause as you do your work, and then resume play to check your answer. All right, this is the work that goes along with number 4. I multiplied the negative 9 and 12 to get 108. Factor treat it down. My group of 3 is right here, and it goes on the outside. And what's boxed in gets remultiplied and put on the inside. So I need to deal with this negative sign, the negative that goes with 108. In a previous lesson, we had talked about when you have a negative number inside an odd root, that your answer is going to be negative. So I'm going to ignore the negative as I work through the problem, but then bring it back as my final answer. So it's actually a negative 3 that I'm going to pull out. The x's, there was one group of 3, so I brought it out. The y has one group of 3, and there's 2 y's left over on the inside. Negative 3x y times the cube root of 4y squared. So let's look now at numbers 5 and 6. And this will be the last 2 problems in this segment. I'm going to get number 5 started and then let you finish it out. We're going to bring it together under one radical sign, just as before. The 2 numbers on the outside, the 4 and the 3, they come together outside the radical. And then the numbers inside, the 2x and the 8x, they come together. Four times 3 is 12. And then go ahead and simplify what's inside the radical. Push pause and check your answer. When I simplified, the 8 times 2 multiplied to give me 16. If you know the square root of 16 is 4, you can skip this step, the factor tree, and just write 4. Otherwise, 4 times 4 is 16, and there's your pair, and it gets pulled out. There's one pair of x's, it gets pulled out, remultiply everything together, and you get 48x. The last problem that we're going to work out is if you have to distribute a radical. We're going to take our square root of 3 and multiply it to the square root of 12. Remember, when you multiply two square roots, you bring the numbers together under one sign. It's just square root of 3 times 12. So the 3 and the 12 come together. Minus, because of the minus sign, square root of 3 times the square root of 6. So they also come together under one radical. 3 times 6. So I'm going to go ahead and simplify. 3 times 12, I get the square root of 36. And 3 times 6, square root of 18. I know the square root of 36 is 6. 18 doesn't give me a whole number, so I'm going to factor tree. I get 9 times 2. 9 factors into 3 times 3. So I've used the 9 and the 18. The 3 is my pair, and the 2 stays inside. My final answer, 6 minus, the 3 comes out, and the 2 stays in. You can't subtract 6 minus 3. These are two separate terms, and they're not like terms. You can only subtract radicals when they're exactly the same. In the next section, we will talk about dividing radicals. And thank you for your attention today.